Alright, welcome to Unit 3. We are starting factoring, which is the first part of Unit 3. Really, Unit 3 is broken into two parts, factoring and then also working with a whole bunch of quadratics. And we've talked about those a little bit in Unit 2, just trying to identify a specific type of exponent. But first, here we are factoring with a greatest common factor. So as far as the objectives go, we are going to define what factoring a polynomial is, and then we will identify the greatest common monomial factor so we can ultimately factor this out of the polynomial. So we've talked about a monomial and a polynomial several times before, but a monomial is just one term. It's a number, variable, or product with non-fractional exponents. We have examples like 8 or 16x or x to the second power. None of those have any other terms except just themselves standing alone. With a polynomial, that's a sum or difference, and we're looking at examples of 16x plus y. That's a binomial, but it's a polynomial because of the two terms, or 8x squared minus 12x, where you see those are added or subtracted. So, once again, referring to these two terms. Now, for the quotient rule, well, please remember, if we have two variables, two of the same variable, what do we do with their exponents? We subtract them. So, x to the 10th divided by x to the 4th, I have said previously, stack and subtract, we get x to the 6th. Y to the 12th divided by y to the 3rd is y to the 12 minus 3 is 9. And x to the 9th divided by x. It's not x to the 9th. Make sure you put x to the 9 minus 1 is 8. X to the 8th power. Okay. For the greatest common factor, again, that is the greatest term that can be divided from, I don't know if I like divided into, but I haven't changed that, sorry, from each term. So if we look at 50 and 20, both of those are divisible by, well, not 20 and not 50, but they both have a factor of 10 that they are divisible by. What about 35 and 21? Okay, between those, for those of you football aficionados out there, both of those are divisible by 7. And when we look at 120, we don't have any currency that has this, but both of those are divisible by 20. I guess we could say $20, but I was thinking of cents. Alright, well, let's explain why 4 is not the greatest common factor of 12 and 24. Some of you may say, well, 4 is a factor of 12 and it's a factor of 24, but it's not the greatest factor of 12 and 24. Both of those are divisible by what? 12. That is correct. Okay. Okay, so looking at the greatest common factor, we want to see what is the greatest common factor of 4x cubed plus 8x squared plus 12x. Remember, that is the greatest amount which you can divide from each term, and it has to agree with the whole polynomial. So when we look at this, the greatest common factor is between 4, 8, and 12, 4, and then x cubed, x squared, and x, all can divide by a factor of x. So 4x is the GCF there. Now, if we're trying to factor that, which we're going to be doing today, the way we'll do that is if we put the 4x, that GCF, aside, put it in front of the polynomial. We're going to always put the GCF outside, parentheses to separate it, and then now we're going to actually divide that, whether you actually do that by hand, if you write it out, or I have a tendency to write it, think mentally about it. So 4x cubed divided by 4x, take away a factor of 1 from the exponent, by the way, but we have 1, or just x to the second power. And then 8x squared divided by 4x is plus 2x. And then 12x divided by 4x, x is canceled, so we are not going to have a variable that time. It's just going to be plus 3. Now this is a good thing to look at, and that's actually the factored form of this. So this would be the answer if you were asked to factor that polynomial. That would be the answer. Something I want you to consider, which is really important, notice how this 3 does not have an x. The 2x does, but not the 3. That's because if you were to actually distribute, let's say you take 4x times the x squared, and just go back, 4 times 1x is 4, x times x squared is x to the third power. Now if we take 4x times 2x, 4 times 2 is 8, and then x times x is x to the, if that's a 1 plus 1, x to the second power. And then also, if we take 4x times 3, 3 times 4, that is 12, and carry the x there, so we have plus 12x. And it does come out to be the original answer. 4x cubed plus 8x squared plus 12x when you would distribute. But again, we are only trying to factor right now. Okay. Here I just have a couple of other examples for you. Something that I want you to maybe, if it helps, you can think of factoring as reverse distributing. Because we are, just as I showed before, one way to check your work is after you get your answer, if you feel like it would be best for you to actually distribute and take that value times all of the different parts, it should come out to the original problem that you had. So that's just one way you can think about it, is reverse distributing. Now with factoring, the two steps that we're really going to focus on, we want to divide the polynomial by its greatest common factor. Now once you find the greatest common factor, you're not done. Factoring requires you to also put the GCF out front and then put the newly found polynomial, or quotient as I have it, in parentheses, and we'll see that with example 1. So, looking at example 1, we have this trinomial, and we want to identify what is the, first you have to figure out what is the greatest common factor. Now if you want to put it aside, you can set it aside somewhere. I might say, maybe above the problem, the GCF, we need to absolutely make sure that we can identify that. That's the first step. Looking at this, 24, 16, and 12 are all divisible by 4. None of you are here to correct me, so I need to make sure I'm right. And with this, x cubed, x squared, and x are all divisible by x. So your greatest common factor is 4x. Now, when we divide all of those by 4x, I'll try it where maybe, if you'd like to, you can actually write 4x underneath each part. Some of you may prefer this, some may not. As you get more advanced and skilled with working with this, you can maybe visualize it a little better. But now what we want to do, in order to write our answer, like I said before, you need to split the 4x away from the polynomial, and now we're going to write the division section in the parentheses. So 24 divided by 4 is 6, and then x cubed divided by x to the first power is x. 3 minus 1 is 2. Now, 16x squared divided by 4x. 16 divided by 4 is plus 4. And then x squared divided by x to the first is x to the first power. Now I'm not going to write that because it's just plus 4x. Then we have minus 12x divided by 4x. So 12 divided by 4 is 3, so I'll put minus 3. X divided by x is x to the 0. And remember, x to the 0, we do not need to write, so I just wanted to show you. That cancels out, and we just leave the 3. So your answer is 4x times the quantity, 6x squared, plus 4x minus 3. Signed, sealed, delivered. On to the next one. Number 2. When we look at this and we're factoring the expression, we only have a binomial, but we have to go through the steps. First, look at what is the greatest common factor between 12 and 36. We can identify that. Here, I'll put that above again. So the GCF, that we can say is 12 is divisible from both of those. Remember, take the lowest exponent, so we have y squared, and then z to the 8th versus z to the 9th is z to the 8th with that lowest exponent again. Okay? So, as you begin or continue, we can divide both of those by 12 y squared z to the 8th power. And as we go through, please remember when you start your problem, I'm going to try and fit enough space in here, but I'm going to put the GCF first because that has to be separated from the divided section. So I have 12y squared z to the 8th parentheses. Now we can divide. So 12 divided by 12 is 1. Y cubed divided by y squared, 3 minus 2 is 1. So we have y to the first power. And then z to the 8th divided by z to the 8th. Those cancel. 8 minus 8 is 0. So that actually eliminates, and we have y, no z. So no coefficient. The coefficient is assumed as 1. And we would have y to the first with no z. But again, I'm just going to leave it as y. Now, with the minus 36 divided by 12, that is minus 3. And then we have y squared divided by y squared. When you do your factoring properly, you'll see how the z to the 8's canceled in the front. The other thing, y squared, should cancel from the back. So now there's one variable that completely eliminates from both parts. Now, we don't have to put that, but when we look at z to the 9th divided by z to the 8th, we have 9 minus 8, so that's z to the first power. Don't have to write the 1. So we have our answer as 12y squared z to the 8th times the quantity y minus 3z. And again, I know that this answer is done because when I look at the y and I look at the 3z, which came from the original problem, just saying, if you compare those with the original, y and 3z no longer have any factors in common outside of 1, and that doesn't matter. So y and 3z, since that's as done as possible, so are we. On to number 3. Now for that, we want to figure out between these three terms, what is the greatest common factor. 99, 81, and 36 are all divisible by 9. So we'll say the GCF is 9. And then we have between c to the 4th, c to the 3rd, and d squared. Actually, you know what? Notice how I didn't even have a c in the back. Because that's the case, and we have to remember this, c cannot be in the greatest common factor. So then we move past c and go straight to all of the d's to see if d to the 8th, d to the 6th, and d squared have anything that we can divide. Since all three have d, then we can include d, which is d to the lowest exponent is 2. So 9d squared is the greatest common factor. So we're going to go ahead and divide each part of that trinomial by 9d squared. So, in preparation for writing the final answer, remember the first part of the problem is where you write your GCF out front, so 9d squared, parentheses. Now we can divide. Looking at 99 divided by 9 is 11. C to the fourth does not divide by anything, so just remember, when you don't have that variable in your GCF, then it just carries through to the answer. So 11, c to the fourth, and then now d to the eighth divided by d squared is d to the sixth power. Next, we have 81 divided by 9 is 9, so plus 9, c to the third. Again, that one just carries to the answer. And then d to the sixth divided by d squared is d to the fourth power. And lastly, minus 36 divided by 9 is minus 4. Now because we have d squared divided by d squared, there should be one variable that entirely eliminates, and in this case it's in the last term. So we are done with minus 4, and we can close that off with parentheses. So our answer is 9d squared times the quantity 11c to the fourth power d to the sixth power plus 9c cubed d to the fourth minus 4. And we are ready to advance. Two more. So for number 4, we have this trinomial. As we look at it, first step, go through and identify what is your GCF. I look at 10, 5, and 10. Between those, we can identify that all three are divisible by 5, not 10. When we look at the x's, all three terms have some factor of x, so we can actually use the lowest, which is just plain x. And then as far as y, if we look, we have y to the fifth, but there's no y here. So we can actually only use 5x in the GCF, and we're good to go. So let's get started. If we divide everything by 5x, start thinking about what the exponent is for that. And preparing our final answer, we put the 5x out front with parentheses. 10 divided by 5 is 2. X divided by x, those cancel there. So we have no x, but we do have a y, which drops down. Looking at the middle term, minus 5 divided by 5 is minus 1. I'm just going to put the minus there. X squared divided by x to the first power is x to the first, but we're not going to put the 1. And then we have y to the fifth. Again, y was not in the GCF, so that carries down into the answer. And then we have minus 10 divided by 5, which is minus 2. And x to the second power divided by x to the first is x to the first, or just minus 2x. So again, here we are with 5x times 2y minus xy to the fifth power minus 2x. Okay, and again, please make sure that as needed you pause at any time to allow yourself room to catch up with anything if there's something missed. But now we have the next example, the last one for this lesson. For number 5, as we look at this trinomial, we want to, again, think about the first step, which is what? Identify the GCF. Now the GCF, as you may have noticed, comparing 54, 81, and 63, all of those are divisible by Well, we look at 54, 81, and 63. It does help to know our multiplication facts. All of those are divisible by 9. And then now the good thing is when we look at variables, look for the lowest exponent if it's present in all three terms. So we have this was just plain 9x and then y to the 4th power. So we can divide the entire polynomial by 9, x to the 1st and y to the 4th power. And then we can actually include that when we're ready. We can start including that in the answer. So I'm going to put that aside by writing it out front with 9x y to the 4th power. And I want to make sure I didn't make any mistakes. We're good to go. Alright, so 54 divided by 9 gives us 6. X to the 4th divided by x. Remember that's x to the 1st, so we have x to the 3rd power. And then y to the 8th divided by y to the 4th is y to the 8 minus 4 is 4. 81 divided by 9 in the next term, we have plus 9. X squared divided by x is x to the 1st, or just 9x. And then y to the 6th divided by y to the 4th is y squared. Now for minus 63 divided by 9, that would be minus 7. X divided by x, that set cancels, and y to the 4th divided by y to the 4th. Wow, both variables cancel, leaving us with just minus 7 in the back. And we are completed with this. So here we are with our final answer. If you have any questions, please make sure to make a note of them, and good luck with the assignment. All right.